So the GCF for this one will be in the front. The GCF will be, I'll write it all together here. So you got the GCF correctly. It's x to the third. Okay. And you think x to the third times what will give you negative 21 x to the fifth? Well, it will be x will be 21, negative 21 for sure. And then, oh, let me think here. Now, this should be acceptable. However, I believe they want you to factor out a negative, but that's not necessarily. All right, let's do it that way. I think maybe you made a mistake. Hey, can you scroll into that yellow highlight part? Do you think you can look back? Because you might have gotten it right, but they want the negative for some reason. You don't have to have a negative. Oh, I see. Yeah, you didn't complete it. So, okay, we'll keep the x to the third. You didn't complete the rest of it. I see what's up. I see what's up. Okay, so it'll be x, like what you got there, minus 42x. I think you got that one too to get to the fourth. But the last one, you see that plus, you still have to do a plus 1. It'll make sense to you there. See it?
Yeah. Toss, are you writing on somewhere? I can't see what you're doing.
Oh, I see. Oh, man. Uh-oh. I think there's a... Let me see how we can do this. You're supposed to see everything, but...
Oh, wait. I got it.
You sure? Okay.
Figure it out.
Okay, good. Oh, boy.
Perfect.
All right.
All right, we're good.
Very good. All right, so you just missed the plus 1, the plus 1 part.
Ah,
You see that?
I see.
Yeah.
Yeah.
To get back the x to the third, you need that plus 1. That's it.
That makes sense.
You can also factor out the negative if you want, but there's two variations of this answer. Yeah. All right, let's put that in or submit it or fix it.
It won't let me change it. I just have to do it on this paper, and then tomorrow I'll show it to her. She's gonna correct it.
All right, let's do that. Now, if you want the fancier version, it'll be this. Okay, let me write 2 versions. You can copy both. Your teacher will be happy about it. So if you do a negative version, x to the third, because it's actually more common in later math, in calculus especially, or pre-cal even. So you can do it like this: 21x squared, and I want to minus or do a plus. Oh, not 4. Okay, 42. Sorry, fix that. 42. Oh, it would be bad. 42x to the fourth. Let me even erase that beneath here. The first version is a minus. Okay, I'll do both version here. 42x to the x. Yeah, just 42x. But this one will be 42 plus 42x and then a minus 1. So let me double check by looking here. That's correct. That is correct. And that is correct. Yes, so you got 2 versions. Either this or that. No problem. You can write both. Your teacher will be happy that you know both. Yes, let's do the next one.
Yeah, let me.
Yeah, I can see the relationship between this and your retake test. Okay, factor completely. Guess what? You did everything you need to except you did not continue. So okay, anyway, let me continue for you, but I'll copy the step that you have. It is correct so far, by the way. Good job here, but you just need to complete it. So continuing, let me double check too. So this is correct, but we have to continue. So let me double check here. That looks so 100 minus, yep, so good so far. So dot here, but then you have to continue here. Now, I'll rewrite it over here for you to see why. The answer is this, but I'll explain why. So it's going to be 2x plus y, 2x minus y. So this will be the final right here. But parentheses, sorry, be I keep writing. Okay, 2x plus y. You could do a minus first, and then 2x minus y. Now, the reason we're doing this is because of the difference of squares. It has to do with this formula here. But before you can even use it, you have to rewrite this to be your complete A. What do you mean complete A? It'll be 2x squared. and then the y stays y. So your a is 2x, your y is your b. See it?
Mm-hmm.
So you have to actually factor out or regroup to get your a, because you may not see it from 4x squared. So if you regroup it with the parentheses, your a now is 2x. So that's why you apply it. That's why you got the 2x plus y, 2x minus y from here. Okay, this is final.
All right. I'll go to the next one.
Okay. Okay, so this one. Now I can tell, let me erase this, that your sign may have to be different. So let me go at it. Let me write the original a little bit. So, I don't recommend you do the x. Do you want me to do the x?
Yeah, that's what I'm used to.
Okay, let's do the x. That means I won't be able to get this right away. But let me go ahead and jump to the answer, and then I'll do the x in between for you. So the final answer will be 3x. Let me double check. 4 here, nope. 2 here, and 4 here. Yep, so this is going to be the final answer, but I'll show you how to get that using grouping method or the x method. And it's going to be a minus here and plus here. Yep, so I'm going to show you the work in between here.
Okay.
So you multiply this with the negative 8 times 3. So it'd be negative 24. Then you have to come up with the two combination that will give you 24, but at the same time combine to give you a 24. So let's see, to get the product of the two is negative 24. The sum is negative 2. Mm-hmm. So let's see, 6 and 4. But you have to get a negative 2, therefore it has to be minus 6 so far. Mm-hmm. And I don't know what to write on here. I forgot what it was. Honestly, I don't know what that is. But anyway, the way you organize this is this. You go 3x squared. It doesn't matter which one. I recommend you use this one that 3 can divide into 6, but then you have to write x and then plus 4. So I'm extracting this here, extracting this here with the x as part of it. Mm-hmm. And x and then minus 8. And then you have to do the grouping, the first two and the last two. So here we go. The first two, you factor out the common factor, the GCF, the greatest common factor will be 3x. And then it'll be x minus 2. And then if this is plus, then you do a plus. Common factor between these two will be 4. 4 times 4 will give you 4x. 4 times 4 will give you a negative 8, will be 2. So when you do this correctly, you'll be writing this once in the front or in the back. So I already wrote the answer. This will be written in the back, and then you have to write this in the front. Now, you see how long this is, and I got the answer pretty much like a few seconds, but I'd like to explain how I got that. It's called try and error, and it is taught. This is actually the second method. It's called AC grouping, the thing we just went through with the X thing. It's called AC grouping. Now, the reason why it's grouping is because it has the coefficient other than 1. Had it been a 1, you would have been done. You would not have to write the 4 terms right here at all. Had this been a 1, or nothing there, but you have a 3, it's going to take some time if you do the X method. Now, let me show you how to do it like a fast way. It's going to look like a double bubble thing. You always seen that when you factor in the end. The answer is going to look like that. So what you're going to do is that you look at what times what will give you the first and what times what will give you the last. So, well, I chose 3x and x. See, that's like, if you multiply them, you get 3x squared. You see that? Is that okay? Okay, yeah. Then now what about the last? Well, there's a bunch of combination. Actually, 2, 8 and 1, or 4 and 2, right? But you want to pick the number that's close to each other. 4 and 2 is close to each other. 8 and 1 a little bit far apart. The product to get you an 8. Don't worry about the sign. But okay. Now, but if you choose 8, for example, and 1, if you foil it, the outer or outside and inside, they're too far apart for you to get a minus 2x back. So you see that it's like 3 times 8. That's too big for you to combine to get you that. Okay, fine. What about if I switch them? What if I do 8 and 1 here? Yeah, you might, but outer it's 3, inner is 8. at most is like 12, at least it's 5 if I subtract them. So it's still not good. That's why you want to choose the closest number first. So I chose 4 and I chose 2. Now you could have chose 4 here, but you realize that it's still big, then you switch them. So anyway, this will, the outside, when you FOIL the outside, why am I not doing the first and the last? Because you already got it. The first is this, the last is that. You know, to get your 8, you get your 3x squared. That's why you only need to do the outside and inside. The outside, here we go. The outside is 6x, inside is 4x. If I subtract, I'll get my 2. That's why these are the right combination. But I'll do another one because this is something you have not done. I can tell for practice, especially with me. I don't remember doing this with you. But then you have to check your sign, which one to give you the the -2. That will go there, and the plus will go here. So same answer. But anyway, this will be the answer. But then the work that you want to show for your teacher would be all of this here.
Yeah.
Go for it. Okay. You copied it already?
Yep.
Okay. Let's go to the next one.
Oh shit. All right. 1 second.
Oh, you want me to bring it back?
No. I was saying 1 second. I'll get to the next one.
Okay, got it. I can bring it back. But okay, when you do this one, you have to do the first 2. I may have to copy this for you to see it, to make sense. Sometimes I never like to copy the original because if I make a mistake, the whole thing will be wrong. But double check what I wrote here. But normally, if I do it correctly, they have to match. So yeah, it's still okay. If I would know if I made a mistake copying it in the next step. Okay, so it looks good. Okay, when you do this, what you want to do is just like what I was showing you on the test, the retake test. Oh, I can't bring it. Oh, I cannot. It's got stuck there for some reason. Okay, so what it is that you don't look at the last 2, do the first 2. Yeah, don't look at the last 2. So the first 2, ignore the last 2. The first 2, the common factor, the greatest common factor will be 2x to the third. I think you're pretty good with this part. And then figure out what will go in between the parentheses. 2x to the third times what will give you this back. Well, 6 for sure. X to the third times what will give you x to the fourth will be x. Okay, I think you got that. And then this part, 2x to the third times what will give you this back, -1. I hope you see that. If you distribute, you get this whole thing back, like this back. Is that okay?
Yeah.
Now, once you're done, don't look at the first 2 and then go to the next 2. If this is plus, you immediately do plus. Don't write it without the sign. Whatever the sign of the third one, which is technically the third one, in the 4 terms, bring it down. And then think, hey, what is the common factor between the last 2? It's 6, for sure, for the number part. But you have to do 6x, including the x. So 6x will be the greatest common factor for the last 2. 6x times what will give you 36x squared. It will be 6x. 6x times what will give you a -6x. It will be -1. Okay, there you go. Now, if you do this correctly, the thing in the parentheses must match. And they did. See? They match. So when they match, that means you did it right. You can write it in the front or in the back. This time I'll write it in the front first. Like this. Oop, 1. Writing this once in the front. And you know what? Let's put it in the back because I'm pretty sure your teacher prefer that. The reason why, because
it usually looks in class, yeah.
Yeah, because it will look more natural. So I'll put it in the back and you see why. If I wrote the front, they normally want the bigger terms in the front. So you write it once, but the one in the front, you must collect them in order like this, one by one. The last, yeah, the same one, you write it once, but the first here, you're going to write it in order. So extract it like the third plus 6x, just like that. There you go.
All right.
Let me double check. Yeah, it looks good. Yep, that's it. Looks good. Oh, one last thing. Dang it. One last thing. It's not done. I'm glad we didn't move on. Did you? Oh, you move on. It's fine. No, fine. Oh, go back to your paper. You have to factor. Okay. I made a mistake. Actually, I should. You know what? But no, it's still continuable. If you made a mistake, I'm glad I looked at it one more time. What happened is that you should have actually pulled out the GCF for the whole thing at first. I went along with what you wrote earlier, so that's why I should have actually looked carefully. You should pull out the X from the beginning first. See that? The X is common in all of it. That's the first GCF you do. But no problem. If you actually already executed, you can still look at the last part and look, or this one right here. And if you see something that you can pull out, you have to pull out, and that will be the last. So that means this can be continuable. You can continue. You're going to pull out 2x. And the last, you keep it as is. And that'll be fine. It works either way, from the beginning or last. You normally supposed to do it from the beginning. And you were taught to do that from the beginning. But it's okay. You have to check your work if you forgot. So there's a way around it. So, okay, so 2x times 12 will give you 2x to the third. It'll be x. 2x times 12 will give you 6x, so it's plus 2. Okay, that's it. Let me double check. Oh, sorry. Squared. Ah, shoot. Yeah. Double check. Yep. What time? What? Yep, that's it. Now, the thing is that you cannot continue here because it's a plus. But that's it. I'll even come back to that later to double check, but I'm pretty sure. All right, let's continue with the other one, but I'll leave that one alone. All right, so you have to solve. To do this, I'll write the original. Oops, 6, 7. Yeah, up x. All right. Again, since you have 0 on this side, it's pretty much easy from here. If you're not, you have to bring everything over to one side. If there is an x term. But okay, next, you want to factor out the common factor again. So x is the only common factor. 67 equals 0. There you go. Now, if you recall a quadratic equation, if you have them factored equal to 0, you set each factor equal to 0 and solve. That will be your final. So you set this one, there's nothing, you set equal to 0. But this one, you set equal to 0 and solve. But then add both sides by 67, so the final is 67. So you got 2 answers. So you got 1, but you missed the other one, the 0. That's it. So one of them is correct, but you got another one, which is 0. So you have to remember to do this part.
Yeah.
Okay, next one. Okay. Yes. Now, if you read carefully, they want you to solve. That means that the x will be like numbers. So I think you were nervous doing this. So this one, you're going to get x because it's an equation with equal to 0. So if you factor, you're not going to be done. Yeah, if you factor, you're not going to be done. So yeah, they say, hey, solve. So x has to be like a number or more. You got 2 numbers as your answer. How do I know if it's x squared, quadratic? You're going to have 2 answers coming. So let me show you. So you have to solve just like the last one because it's set equal to 0. So I'm making this up. Had it been written something like this, I'm making this up. Had it been written originally like this, you would have to subtract both sides by 15 and have a 0 on the other side, just like what you got there as a problem. See it? So this is actually, yeah. So this problem could have come from this problem right here. The next step would have been that, the way you see it there. But I'll go ahead and write exactly this. Now you continue. So we want to do the factoring again. Now let's try the fast way, okay? The teacher won't mind if you write this. So let's try it the way I was showing you a moment ago. The reason why you want to do it because of this here, because it's faster than doing the x, and it will take you a while. Like you have 2 steps in between. If you notice, this one you only write 1 step, but we're gonna do a good educated guess. So you're gonna guess the product of the first and the product of the last, but ignore the negative for a second. The product of the first will be 3x and x, writing in the front, and the product of the last, you write it in the back. So the product of the last is like 3 and 5. Remember I was saying, don't use the 15 and 1. They're too far apart. Let's use 5 and 3. But let me see. If I choose 5 and 3 here, this will be, don't write this yet. I'm testing it out. So if I do that, I get 15. And if I do this, I get 3. If I add, I get 18 at most. If I subtract, I still not going to get a 4. That means this is not the right combination. So, okay, but you said that you don't want to do 15 and 1. Yeah, but I haven't switched it, the 5 and 3. So this should work. Okay, let's see why. Here, now we're going to test it. This is going to give you 9x. This is going to give you 5x, the outside, inside. If I subtract them, I will get 4. But I need to make sure it's a minus 4 So therefore, where can I get the negative? I want a negative here. Therefore, the only way you can get a negative out of that is having a minus 3. Negative 3x times minus 3 is negative 9x. See it? And then this has to be a 5. That's it. If you ever do foiling, you'll get all this back. That means this is correct. Now, this is actually something that college students do it all the time. They never do the X thing ever. I take that back. The grouping, you can still do the X if this is a 1. If this were a 1, then you can do the X. But if it's a 3, they would prefer to do a guessing or try and error. It's a one of the method in Algebra 2 that it is in the textbook that is taught. And your teacher is supposed to have gone over this, by the way, if he or she didn't do it already. So this is actually the second method, or the first of the 2 methods. Likely the first one, but I don't remember which one is first. And then the AC grouping, it's one of them. Anyway, okay, and then you have to set each one equal to 0. So let's do that. X minus 3 equals 0. This one, subtract both sides by 5, divide both sides by 3, subtract both sides by 5, divide both sides by 3. So it's going to be negative 5/3. I recommend you put the negative in front of the bar, because if you put this in that system, it will tell you that, hey, you should be writing as a negative number. So here's what I mean. Why is this thing? Sorry, let me make it a little smaller. Look, so this is correct, but one of my students did a problem that's similar, and he put the negative in the numerator, and the thing says, hey, put it in the middle as a fraction. So like there. Subtract both sides by 5, divide both sides by 3. And then x equals 3, add both sides by 3. These are the 2 answers here. Double check. Yeah, it looks good to me. Yeah. Oh, yep. Okay, you got it? Okay, next one. Say 4 terms again. So what you want to do is don't look at the last 2, start with the first 2. But I'll copy this so you can see it. So you want to look at the first 2 and ignore the last 2. Now, in textbook, they write all weird things, with this. I'm sorry, in class, they write this little step thing and then put this in and put that in, like the first 2, factor the first 2. And the book could be using a parenthesis plus another parenthesis, but not multiply. So where I work, under college professor, they prefer don't put anything, don't put parentheses, don't put anything, because you do parentheses, you might mistaken it by multiplying, which is entirely wrong. And sometimes they don't put the sign, that is also wrong. And that's happened a lot in high school when the teacher's writing it with the parentheses. It's bad. I've shown some of the work to my PhD professor who worked like for 40 years, and they have multiple PhDs, by the way. No kidding. But anyway, so they prefer that you do it clean, like ignore the last 2 and then factor out the first 2. So the first 2, the common factor is x squared. So yeah, look carefully out of this whole thing. There is no x that you can pull out for the whole thing. So therefore, therefore you can go at it, the first 2. So x squared times what will give you 2x to the third, it'll be 2x. X squared times what will give you 5x squared, will be just plus 5, like that. Okay, now, then ignore everything, the first 2. The last 2, the third term is a negative. You have to write a minus. So you have to come up with a minus factor. So it's a minus 1. This is a trick problem. What's common in both of them? None except 1. But you can't just write 1. You have to do it. It could be a plus 1, but this is a minus because of the rule that you're supposed to follow. If the third term is negative, you have to pull a negative out. And what is the number? It'll be a 1. It'll be a negative 1. Then you can do the parenthesis here. So now you think negative 1 times what will give this whole thing back? Negative 1 times what will give you a negative 2x? It'll be just positive 2x. Negative 1 times what will give you minus 5 is a plus 5. So there it is. Now you do it correctly, they will match. There you see? There it is. Then you can write this in the back. This one is continuable. Oh, wow. What I mean by that is you'll see the first 2 will be continuable here. So you write that once in the back, then you write this here, and you write that here. X squared minus 1, including the sign. So, and then equal to 0. Now, you technically can solve if you know that there's 2 answers coming from here. If you don't want to do that, you can continue and factor it. But let me see. Let me see if you're gonna. Let me see. For example, if you were to solve this, how you want to set it equal to 0. Do you remember how to do this one? I mean, you might prefer this. So if I were to do it here, I add both sides by 1, I get this. And then, do you remember how to go from this step? Let me see. Oh yeah, this is already set. How do I continue from here? Some people do it this way because it's a little bit shorter instead of factoring it up here. But let me ask you, if you were to set it equal to 0 right away, how would you solve this next step? I add both sides by 1. Do you remember how to solve for x in this one?
Not really, no.
Okay, if you do this one, you square root both side things. I don't run right that, but the thing is, you square root it and you get a plus or minus root of 1, root of the other side. Okay, I think you might remember that. Okay, but this is why I think, but then the answer in the final answer would be plus or minus 1. That means if this is not too familiar to you, you want to factor it. How? This 1 is a perfect square, just like it's like a 4. I'm making this up. If this were a 4, then you do a plus 2 minus 2 here in x. Don't write this yet. You remember something about that?
Yeah.
If this were a 25, a minus, it had to be a minus. If this were minus 25, then we a plus 5 minus 5 and then x and x. 25 here. Now, the 1 itself is also a perfect square because 1 times 1 is 1. So I recommend you actually go at it like this. So it'll be x plus 1, x minus 1. There it is. So yeah. So try to remember, look out for something squared by itself like this and a minus. That means normally it's continuable. If this number back here, it's a 1, 4, 9, 16, 25, the perfect square numbers, then you will try to do this every single time. Okay. So let's go this way. Then copy this down. Now we set every single one equal to 0. So I think I won't write the part where it's set equal to 0. I'm just going to write the answer. X equals -1. Subtract both sides by 1. X equals 1. And then x equals, subtract both sides by 5, divide both sides by 2. So I'll write it as a fraction. Like that. So there you go. 3 answers. X equals -1. X equals 1. X equals -5/2. Your teacher won't mind if you actually write the answer or opposite when you jump from here to here, because you've done one before that. You show the work before that. Okay, next one. Okay, so this one, you would do the same. You'll have to factor that. Yeah. Now, this one, you can do x. Oh, wait, let me write it first. Because you have a 1 in the front. If you don't see anything in the front, there's a 1. But let me go ahead and do it without first. Then I'll show you the x will work nicely. And you won't have a weird, like, multiple step in between. If and only if this were a 1 and you have it. So, okay, let's go at it by factoring. Watch. Now, I know this may be even if you were to do the X thing, you still have to come up with the combination. It's still the same, by the way, the guessing. That's why you may want to prefer to do this no matter what. Because you're about to come out, if you write 70 here, you have to come up with a 2 combination that will give you a -14 anyway. Do you see that? So, but you won't have to do like the 4 terms thing. That's the only time when you don't have to worry about that, because this happened to be a 1. So when you get the combination, you're done right away. So let's kind of get some combination. Now, how would you know this? Well, I don't know, like 7 and 10. That's the first thing I see. But the thing is that if I combine, I will never get 14. Yeah, don't worry about the sign, the negative yet. I can't get that. But what about half of this thing is like 35 and 2? 35. Yeah, I'm never going to get 14. Now, if you exhaust your, like, combination that you can come up with, I recommend you do something methodical like this. Yeah, I'll be honest, I don't know. I don't know what two numbers times each other will give you a 70 and combine to give you a 14. I don't know it. 7, no. So what you can do is go ahead and factor it out, like prime factorize it, and then I'll show it to you. But then you circle the prime number. I recommend you write this. Your teacher will be happy that you like break down your work and figure things out. So here, so I see what's up. I understand now. I didn't read the instruction. They want you to complete the square. Hey, can you go back to number 7? You have to follow the method. So we cannot do it by try and error. Cannot do it by X method. Could you go back and see if okay, this one is fine. I'm happy. Then this one, we cannot do anything other than completing the square. Sorry, I didn't read the instruction. You have to follow a particular method. So if ignore the x thing, you cannot do the x thing or the guessing thing. So complete the square. So I'll write a note here. Complete square. Complete square. So you have to complete the square equal to 0. So completing the square goes like this. You have to make sure you identify your A, which is 1, your B, which is negative 14, your C, which is going to be 70. I think you remember that, right? Like the it's called the general form of a quadratic. So anyway, you take your B, including the sign, 14, divided by 2, okay? And then you're going to square it. But before you square it, simplify it in between the parentheses first. It will be negative 7 in the parentheses, square, like that. Okay. Oh, I apologize. This is algebra 2. If this were pre-cal and above, you won't have to do this. Okay, wait, let me have you do something first. You, according to what I remember from you guys are supposed to subtract 70 over, which I never do because I don't need to do that. But I believe this is what you do. Sorry. So before you complete the square, you want to subtract the number part, like the 70, like, no x, non-x term. Subtract both sides by 70. It'll be negative 70 over here. Is that okay? Yeah, just kind of erase and skip that and write it like that. So yeah, before you attempt to do the completeness square, so I pretend I started that way. I subtract both sides by 70, and then I continue. Okay, I'm done with that. And then I take the B, negative 14, and divide it by 2, and parenthesize it, and then square it. That's just the method. So when I square it, I get 49. That means I'll add 49 to both sides. It's just like a special number that you come up with, and then you continue from there. But you can't do anything. You cannot just come up with any number. You have to come up with the number this way. So add 49, completing the square to both sides. Okay, now all you do is continue. How do you continue? You factor this thing. Now, how do you factor it? Well, it goes, what is this? Negative 49. I'll use a calculator. I'm not that smart now. I'm a little worn out. Sorry. Negative 70 plus 49 in the calculator. Plus 49. That's negative 21. It'll be complex because it says right there, complex number. Oh, you get an I coming out of this, imaginary number coming out of this. But anyway, this side can be factored. Now, how do you do this? You can guess the combination if you want. Now, close this number to each other is 7 and 7. 7 and 7. But then, how do I get 14? Yeah, I can get 14. I can add them, but I need to I have to make sure it's a negative and negative. You see that? Mm-hmm. There it is. Now, I did this on purpose. However, if you don't want to do that and you do completing the square, it's always this number after you simplify before you square every single time. Yeah, even if this were a fraction leftover, like reduced fraction, you're still going to add them without having to worry about it. It will always be true. So anyway, I just want to point that out. Yeah, that's why I don't want to do the whole thing one shot right here. 49 here. I don't want to do that. I want to show you. It's always the number that you simplified in between the parentheses divided by 2 if it's reducible or can be divided by 2, which in this case you can, negative 14. Just before, once it's cleaned up, you will always going to use that number right here every single time. So there you go. But anyway, you're also going to square that and add it to both sides. Okay, continue. This now will be x minus 7 squared. You're okay with that? When they're the same, you write it as a square because you need to, because of this completing square method, and copy the negative 21 over. Then continue here. The next step, you have to do this square root both sides. I don't do this, but you can copy this down. I'm about to copy this down. I'm going to erase it because where I work, I'm not allowed to do this. In high school, you can do it. Yeah, I'm sorry. I've gone over this so many times. Yeah, high school teachers still doing this because they learn from each other. I don't know. But in college, you do this, it's wrong. So, but you copy this because it's correct in high school. For some reason, I'm sorry, dude, I don't understand it. Okay, so copy this. Okay, so next step. You're supposed to write this next step. You drop, when you square root a square, you're supposed to drop this thing here. But on this side, still copy the plus or minus symbol and negative 21. But yes, sure, you can copy it like that. But then continue this way. On this side, it's a negative 1 times 21. Or better yet, I'm sorry, erase the 21. do the factored form. 7, 3, 3, 7, doesn't matter. But there's nothing that can be repeated. Like there's no 7, 7, no 3, 3, or perfect square, like a 4, a 16 inside. Therefore, you will leave 21 alone. However, this -1 will be an I. Remember, like an I in front. So you'll do that right now. But let me extend the canvas here. Okay, continue on here. Oh, yeah, copy this also all the way down. So here we go. The next step here, you will pull out this as an I. When the -1 inside the root, it's a -1. A root of -1 is always equals to I. You can copy this on the side. Your teacher will appreciate that you recall things and then you use it. So here it is, I coming out from here. But the remaining root cannot be simplified. So you'll leave it in there, but you want to leave it 21. So almost done, almost done. And then it's long, but this is yeah, that's why you cannot come up with a combination. I was trying to get it. There was no combination. So this is it. You have to do complete the square. So anyway, add 7 to both sides and you're almost done. But how do you write the answer? Squeeze the 7 in the front of the plus and minus. So add 7 to both sides. It'll be neat here. So final answer, x by itself now. Squeeze the 7 in the front. Even if it were a minus, you can still write a -7 in the front here, but it's a +7, plus or minus I root 21. Final answer. Yeah. So there are two answers, a plus and a minus of 7 and I, 7 plus I root 21 and 7 minus I root 21. So there you go. That's the answer. Pretty sure. Pretty sure. Yeah. Okay. All right. Okay, good. Next one here. Okay, this one. Solve the complex. Same thing, same idea. All right, we're going to do the same thing. You want to look for the GCF? There's no GCF. Yeah, but this is not a fun one. I'll show you why. Wow, you know what? I can tell you something here. The problem that you're doing here, well, likely, I know how to explain this. I know how to say it. Well, likely, okay, let me add. Remember, I'm going to subtract both sides by 19. So leave a little gap here. Leave a little gap there. Subtract, pretend you, this is my next step, okay? I'm not going to copy the original. Pretend I subtract both sides by 19 here. And now, 0 minus 19 is -19. Now, what I'm saying here is that you're about to see something very messy here. And normally this problem will be for like honors or accelerated algebra 2. Okay, what do you mean? Well, you cannot complete the square until this is a 1. Your B, like there's your B, this is your A, but your A need to be a 1. Normally, the way you do it is that you divide everything by 3 to get rid of it, to make a 1. But when you do that, you gain fractions everywhere, and then you have to deal with it. That's what I mean about it being messy. So you have no choice, dude. So this problem, the answer is really messy. We'll see what happens here. So yeah, divide everything by 3 because you're not allowed to complete the square without this being a 1. And now you got a 1. So let's see what it looks like. So I'll copy this.
On this one, are you supposed to use the quadratic formula or use the complete square?
Thank you. Good job. Oh, good job. Thank you. Yeah. It would have been, there's nothing wrong. It's just you have to deal with fraction. All right. Thank you so much. Oh man, I didn't read that. I'm old, man. I'm old. So no, yeah, don't subtract 19 over. Sorry. You will do quadratic formula. So thank you for pointing that out. I did not see that. I don't even see that phrase in the back. I didn't see that phrase in the back. You know what? I saw the complex, the phrase complex number. I thought was the same thing as the last one immediately. So here's the formula. You're right. Good job. So we don't, oh man, I'm happy. So I'd rather actually do this one than the other one. Wait, let me write the formula again. You could write this. Your teacher wouldn't mind writing it because you want to use it. So you want to recall and then, 2a. So this is what you'll be using. Now, in college, you box the rules or formulas that you're going to use. You circle the answers. That's how we do it. That's like the tradition. Not all the time, but most time. Professor, you do it. Students tend to follow it. But it's okay. Sometimes you box the answer. I understand that too. It's okay. Anyway, your A, your B, your C. So your A, B, and C. Okay, here we go. X equals -b, so it's -8 plus or minus root of 8 squared. 64, but I'll write it like that first. 4 times A, which is 3, times C, which is 19, positive 19, divided by 2 times 3. Yeah, just show the substitution, and now we'll start cleaning it up. Now this part, I'm gonna punch the whole thing in the calculator in one shot here, in the root here. So I'm gonna, the teacher won't mind, I'm pretty sure. So it'll be 64 minus 4 times 3 times 19. It will be a negative because it says complex. I haven't actually hit enter yet. It says complex. It will be a negative here for sure. 4 times 3 times 19. So 64 minus 4 times 3 times 19. Yes. So it'll be a negative 164. 164 all over 6. Okay. All right. Now you have to rationalize the root 64. So it'll be a root 1 times, and now this time I'll split it. It might be like I'm doing the work here, but it's just on the side work here. So it's the same thing. I'm just extracting this here. 1 second. I'm doing my scratch work here. So it's a root of negative 1 times a root of 164. This is an I. So I'm doing this thing here. You can do the whole thing. Point out that your scratch work is here. A root of negative 1 is I, but a root of 64, you gotta do some math here. Okay, so something like prime factorize it, a little space wherever. So I don't know a perfect square coming out. Oh, I think it's divisible by 16. So 164 divided by 16. Nope, but it is divisible by 4. 4 times. Let's do a little different because I never work with you. If I were to do it, I would do it about smallest, like 2, but I think most of you guys would do something bigger. So I'll do a 4. So 4 times, what will give you 6? 4 times 41. I think 41 is a prime number. So that means I'm glad I did this way. I was about to do 2 times something, but yeah, do 4. Yeah, 4 times 41 is 16, 4. I think you can see why. I'm pretty sure, okay? But this is not continuable. That means it'll be a root of 4 times a root of 41. Now I want to check if that's a prime. There's this app called Woosram. Let's see, 41 prime. Is prime number? Is a prime number. It says right there. Yeah, you could Google it. But this is for like college and engineering students, science and math students, high level math student. But some high school student know how to use it. No biggie. So here we go. So I think you understood how I did that, and then it means if I recollect this, it'll be I times 2 root 41. If I continue there, but they normally write the I in between them. So here's the final, or almost final. But you want to show this first. 2I, squeeze the I in between the 2 and the root 41. 41 prime, you cannot continue. You cannot factor that further. 41 all over 6. Now, the shortcut from here, I mean, you can do so many different ways. What number can divide all 3? 2. So I'm going to do this one shot. 2 can go into negative 8 4 times. 2 can go into 2 1 time. So I'm not going to write the 1. 2 can go into 6 3 times. So here's the final. I divide all the numbers by 2. There's your final answer. Plus or minus. There we go. If I write it clean, I'm confident that I didn't make a mistake. Yeah, 2. Yeah. Now, there's reason behind doing this, by the way. You can factor out the 2 and then cancel it out. 2 can go into 6 3 times on the bottom. Imagine that. Same answer. But this is like a little fast way. Okay, next one. Okay, I don't understand. They gave you like the harder ones. Now it's the easier one. I don't understand it. Yeah. Okay. So same idea. This one is like the beginning stage of completing the square. We did the whole completing the square. So anyway, the C is the back one here. The C is here. So to come up with that, it's like you take 24 divided by 2 and then square it. Now again, this thing that I was doing earlier and now can be a bit different. But if you follow it this way, this is what college professors tend to do. I work under them. I'm their assistant, like associate assistant professor. So that means they know what they're doing. I'm not saying the high school teacher don't do this or anything because I don't know that for sure. Anyway, it'd be 12 here squared. This is the one that you're going to use in a second, like I was saying earlier. But it's 144 is what you're going to add to both sides. But you don't have the other side. You're only going to add one. You know how you're going to add the other side? But you're not going to add it because you don't have any equation. All you do is add it one time here. That's it. So that's going to go in the blank there. Yeah, you want to write the work, you just fill in the blank like that. And then the factor will be x. I know I showed you earlier, like right here, right away. It's really going to be, if this is plus, it's x plus 12 squared. But you can write the factored form, either one. So that 12 I was saying earlier, before you square, if it's simplified, then yeah, that's it. Here it is, that's the answer. The factored form, or you can write either one, it will accept it. Even the computer, if you were to punch this in, the factored one, the expanded one, or the one with the square, it will accept. Anyway, let's continue.
Hold up 1 second, I'm almost done.
Yeah.
There we go.
All right, let's see. So simplifying, I'm glad I've been doing the prime factorizing, so you get to see like how I tackle the roots. So the A is not an imaginary one, but we still have to follow the prime factorization method. Now, I don't expect you to know this one. Like for example, do you know that half of this is 64? Let's see you if you remember it. Do you know 1 to 8 is like half of it is 64?
Yeah.
Okay. Now you can see it now. If you don't know, if you can see that, you want to do that right away. If not, you have to break it up like a bunch of steps, right? But there's so many trees you're going to break from 128. But if you can get the biggest perfect square, which is 64, then you want to do it. So here's what I recommend you do. You want to stop right here. So if you want to show the work for A, it will be like this. 2 times 64, or 64 times 2 is even better, but I'm pretending I'm a high schooler here doing it. So the root 2 cannot be pulled out, but the root 64 can be 8. So it becomes 8 root 2. So that's the final answer. So there it is. But the root 2, you keep it in there. And that's the A. The B. Now the B, I don't recognize what number is in there. That is a perfect square, like the biggest, so I'm going to prime factorize it entirely. However, you have to see that negative. That negative will come out as an I, so be ready for it. But I'll write it like 108 here. But I'm going to write the I waiting for it right now. So the I will be, that'll be the I here. You can do this. I'm sorry. Copy this down, like the next step. And then you're gonna you're gonna rationalize the root 108 separately here, and then you continue carry the I all the way down. So your teacher likes this. This is actually pretty good show of work here. So you like arrow from the negative out here. It's really a root negative, okay? Not just a negative. It's a root negative 1. But teacher understands. Okay, here we go. I don't know the perfect square, so I'll do half and half. Half of 108 is 54, 2 times 54, and I continue here. Okay, now I do see it. It's a 9. Anyway, okay. From here, I do recognize the 9 as a perfect square. So I will do that. I will copy the 2. 9 times, what is it?
7, maybe?
6. Dude, you should know your timetable too. I've been doing this all day. Yeah, 9 times 6 is 54. Okay. Here's the thing. So this here, 9 is the only number. Look, pretend you didn't know that. No, let's just do it like that because most of you guys would do that. So, okay, the 9 is a perfect square. So what I'm going to do is I'm going to write 9 first. But then the 6, if I were to continue, it would be 2 times 3. Okay, this is the messy part. Okay, so let's do it methodically. So I take that back. Erase the 9 times 6, please. Let's do it this way. Pretend that you didn't know that. Pretend you skipped that timetable. So I'm going to half it. Half of 54 is half of 50 is 25, 26, 27. So it's 27. So I circle the prime number. 2 is the only even prime number. Continue on with this one. What times? Okay, it's 3 times 9 and 3 times 3. Now this has to be near the problem, so your teacher will understand it. Okay, so from here, every pair come outside once. So I times 2, every pair come outside once. That's going to be a 3 and times it on the outside. And then there's a 3 left inside, so root 3. So the final answer is going to be 6i root 3. I'm going to put the 6 in the front and the I root 3. My I looks weird here. Yeah, yeah. The perfect square number for this one happens to be 27. But you wouldn't know that, by the way. Let me double check. Yeah. But anyway, this is the answer. Perfect square. Yeah. Yep, that's it. 3, 2, root 3. Yep, there it is. You remember something about the prime factorization, right? That's the way you normally do it if you go all the way and you didn't actually pick up like a perfect square in the tree somewhere. Even if you do, it's going to be kind of, I don't know. I saw a 9. I want to put it there, but I think you might get confused. So I just continue methodically like that. Anyway, C. Sorry, try to get this thing fast here. C. Okay, a negative. Now that negative is on the outside, so it's gonna stay on the outside. But this one is for B. Okay, no for. Sorry. What is that? For B, yeah. For C, the negative will stay. It's not gonna give you an I. It's just on the outside. So it'll be a negative number. So let's break that down. Root of 169. What number can? Okay, I think this may be a prime. If it's a prime, then you're done. 169 prime. I could be wrong. No, I actually know it's not a prime. Dang it, I know it's not a prime. It's 13 times 13. So it's so pretend, yeah, you could write this on the side if you want. Here, 13 squared equals 169. Erase this though. Pretend you didn't. Your teacher will, like, yeah, you remember this. No, it's a thing that you normally not. Many students do not go up further than 12 times 12, but it's negative 13. Final answer. But you're supposed to be exposed to it, and I knew it. I'm tired, but yeah, I knew this number. I know 13 times 13. I know 16 times 16. I know 15 times 15. 14 times 14, I do know. And then nothing beyond 17. I don't know 17 and beyond. Yeah. But 20 times 20, of course, that's not, I mean, D. Yeah. Last one here. Now, this is a combination of negative and I. So be ready. So here's a negative here, and there's negative 36. So this one is easy. You have a negative independently from the outside, and a negative 1 as a root, as an I. So it's going to be I on the outside here. So you pull out an I, a negative independently on the outside. Wait, you want to show the work? I'll show you. You can write this so your teacher believe you that you understood this. Okay, erase that and do it this way. It's a negative times a root of a negative 1 times a root of 36. There you go. This is how they actually would show the work in a textbook. So you break it up like that. Then this negative came from here. So it stay negative, but this is an I. I know you know that. It's a definition of a root negative. But then this is a 6. So times 6. Then you rearrange it as a 6i, final answer. You could leave it right there, but I recommend you write it like this. This is more standard. There you go. Final answer. For sure. Negative 6i. All right, next one. Almost done.
Yep.
Okay. This is about that concept. Now, if you don't want to look at anything in between, or actually you have to, no, because you know your I square is negative 1. I'm glad. That means the rest of it, there's no I to the third. But I just want to point out, if you ever see I to the third, you need to know that it's negative I. So that's the only thing, okay? But the rest, let's do it easy. How to do it? I think you might remember it by now, but let's review. It's going to be on the test, okay? So if you ever see a problem, wait, let me go and make sure that you do know it. I'm going to list it one time. I'm not going to show the work in between or anything. I is a negative 1. I squared is, I'm sorry, I is a root negative 1. I squared is negative 1. I to the third is negative I. I to the fourth is 1. So keep in mind, if you ever get one of these, you're only allowed to write I, negative 1, negative I, and 1. But now, if you ever see anything beyond that, I to the 55, the method that you always want to do, trust me, and you don't have to show any work, just do it this way and you'll be done. Your answer will be I to some power. You might be able to continue here, but we'll see in a second. But the box here, the answer is the remainder every single time. Okay, try to remember it. So 4, you have to divide by 4. Do your long division neatly. Your remainder is the exponent. And if it's simplifiable to one of these, then you're done. So let's do it again. So here, 4, 1, subtract, 4, and then bring down the 15. 4 can go into 15 3 times. And then subtract, you get 3. So the answer is I to the third. That means it's a negative I.
Yeah.
The final answer. So that means you must know these. It will start repeating after 4. So all you need to know is these 4 here. When you do I to higher power, it's going to fall into one of these. Now, there's an extra one. If you have I to the 0, it's always 1. They're the same. Okay, so be ready for that too. Anything to the 0 power is 1. That's why you're going to be ready for that. What do you mean? Because if you have a 0 remainder, the answer is 1. You still put it. You can put it in the exponent of the I. Okay, so I to the 156. Again, long division. 4, 15, 6. Okay, remainder is your answer. It's going to be I to the remainder power. So let's get ready for that. 4 can, didn't we do this one? No, anyway. 3, 12, subtract to be 3, bring down the 6. It's 9 times. So it's 39 exactly. So here we go again. I was thinking that. So you get a 0 remainder. That means you'll put I to the 0 power as your answer, but that is simplifiable to 1. So the final answer is 1. I to the 56 is 1. It means that it's divisible by 4. If the exponent is divisible by 4, it's always equals to 1. But if you didn't know that, do long division. So again, I 71. It'll be I to some power, the remainder. You can write a note, remainder. Yeah, remainder. So long division, 71, 4. 171 time, 3. Bring down the 1. 7, 28. 3. So I to the third is the answer, but I to the third it's actually simplifiable to a negative I. So final answer for I to the 71. Okay, the last one for the I here, I to the 57 equals to I to the remainder power. But if it's continuable, then you have to do it. So here we go again, 57, 4, 7, 4 can go into 17 4 times, it'll be 16, remainder of 1. So I to the first power, that is the answer because I to the first power is just I. That's what you're allowed to leave. Yeah, I to the first power is still I. It's one of these here. So you're allowed to write I, negative 1, negative I, and 1. That's it. So these are the answers. Yeah, they wrote the row on top backwards, but yeah, they do that just to challenge you. Okay, next one. Simplify. Okay, I'm not going to copy the original for A because there is no minus in between, but the B I'll do it. So I'll add negative 41 to 44, negative 1 plus. You're supposed to show the work, right?
Yeah.
Yeah, okay, so the next step from there, it'll be negative 41 plus 44. This is your next step. You bring the number part together, and the 3i is a plus 3i minus 2i. So this is your work that you want to write to show the work. So you want to write it in terms of a plus bi. I think you're familiar with that for sure. So it'll be a 3 plus I, 1i, just 3i. Double check there. The reason is because, yeah, you just combine them. Take out the parenthesis, combine like terms. Take out the parenthesis, combine like term for A. Yeah, so that's it, 3, and yeah. So that's your A. Your B, I'll have to actually distribute the negative for the second part, so I'll write it now. So I'll write the first part without the parenthesis, 43 plus 43 minus 2i. Distribute the negative. It would be plus 42 minus 5i, so far. Double check. Yeah. And then combine these two here. You don't have to write them side by side. So just go ahead and arrow it, or you don't have to arrow it at all. Just write the answer, the final answer. So that will be 85. And then the negative 2i plus negative 5i, that's negative 7i. Final answer. 85, yeah. Plus, minus, yeah. Okay, C. Oh man, there's already a gap there. C. This one, you'll have to FOIL it. So next step, write the expansion of that because it's squared. I can tell you attempted it, but let's see it again. So rewrite it twice and then FOIL it. First, negative times negative is positive 4. Outside is a negative 6i. Inside is negative 6i. Last, it's a plus 9i squared. But keep in mind, I squared is going to be 1, negative 1, I mean. But here, let me make the I clear. Okay, continue next step. 4 stay 4 minus 12i, my I, plus 9 times negative 1. Okay, don't forget the I squared is equals to negative 1. And if you show the work, it'll be 4 minus 9 minus 12i. I'll be neat about it, 12i. And then the last step, negative 5 minus 12i. It's a lot of work, but you just have to be neat, you know? Yeah, you have to be neat.
Yeah.
Pretty sure. Double check here. Yeah. Negative 5 minus 12i. Okay, D, last part of this one. You distribute. Let me copy the original in this case. Distribute this there. So it'd be 42 I plus 6i squared. 6i squared. But then the show work is this part right here. Copy down the 42i. It's 6 times negative 1. Right? Because it's I squared. Then rewrite it. This is going to be a negative 6, but you're supposed to write the negative 6 first plus 42i. Final answer. Because you want to write it as A plus BI. Okay, that's it for that one. Yeah, I can see that you got it, but you didn't finish it off. You know, like that one right there, the 2i. So I hope you commit that the four terms, the definition of the i's. Yeah, memorize that. Okay, the conjugate. You got that? Yeah, the opposite, the sign. And what about the product of the pair? Well, there is a formula, but if you don't remember the formula, just write it out and then do the math. So the original is 12 plus 10i. The conjugate, they want you to multiply them. So we'll do that right now. There's a formula for it, but let's just do the math. So you got this conjugate correct. So you have to FOIL it. First is 144. Now, outside, inside, they're supposed to cancel each other out. So you don't have to do that. All you do is the last, but I'll do the whole thing so you can see it. So the first is that, the outer will be negative 120i. Inner is the positive 120i. And the last, a negative 10 times a positive 10 is a negative 100i squared. There. But then this 2 cancel out. So you only left with 144 minus 100 times negative 1, because I squared is negative 1. But then if you combine them, it'll be 144 negative, negative 100 times 1 is a positive 100. So the final answer is 244. No I, nothing left. If you do a conjugate, the I will go away. Yeah, so that's going to be your final answer. What is the product of the conjugate pairs? Yep, 244. Okay, x, y-intercept. Yeah, this is a bit more challenging because of the square. My student were just doing the linear 2 hours ago. Okay, so if you recall, I recommend you write the y in place of the f of x. And you might want to consider doing the table. You don't have to. If you do x-intercept, your y must be 0. You have to solve for x. If you do y-intercept, your x is 0, your y is what you're solving for. The concept is that, if you go through there, you don't know what your x is, but you know your y. That's your x-intercept. If you go through there for your y-intercept, you know your x is 0, you don't know what your y is. Now, if you wanna, you can, if you wonder how that came about, or you can just memorize it. If you do x-intercept, substitute y with 0 and solve for it. Solve for x. If you do y-intercept, you substitute x with 0 and then solve for y. Okay, so do x-intercept first, so x-int. So here's the show of work. X-intercept, your y must be 0, then solve for x. So I put y equals 0 here. And don't tell me we have a quadratic, like the answer is a root. I don't think so, but we're gonna do. Yeah, if it comes out as if it comes out as a negative root in a quadratic formula, let's say we have to go use quadratic formula, then you have to say none. It does not exist. But we haven't tried it yet. This is 0, okay? So we're gonna try it right now. But I'd rather do the try and error first, the guessing method first. So 2 times 2x, the first 2x times 2x, the last 3 and 3. Let's see if it works. If I do the outer, that's 6. Inner is 3. 6 subtract 3. I'm not going to get a minus 2. So it does not work here. But what if I do 9 and 1? Outside is 2, 9. If I add, it'll be more like 11. If I subtract, I get 7. Nope. That means you will have a quadratic formula. So, yep. So we're going to do a quadratic formula here. Better than completing the square, So that's 0, okay? This is 0. So we're going to do quadratic formula. Attempt. Now, I have a feeling we don't have to complete it. So we're going to do x equals negative b. This is your b. Negative 2 plus or minus a root of negative 2 squared minus 4 times a, which is 2 times 9. Okay, I'm right. So guess what? You don't have to continue, and here's why. At least you set it up to show that, hey, I'm about to get it, but I can't. It's 2 times 2. So here's why it's not going to work. So I don't recommend you continue writing the step. This is going to be 4 minus, okay, I'll write underneath here, somewhere here. So it's a 4 minus 8 times 9. 8 times 9 right here. 8 times 9. 4 okay. 72. So I'm going to get a negative number inside the root. So if you want to show anything, you go like this, dot, 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 plus a negative number. No kidding. Just write exactly this over 4. When you have a imaginary, like I, you cannot graph the I because you on a real plane. Then the answer you say for x-intercept, none. So I don't know where you want to write x-int, none. Yeah, so when you were doing this online, I'm sure there's an option where it says none or an empty set, like a whatever. So this is none. Or show, like if you're going to show the work for your teacher, say none. Now, how does that work? It looks like this, dude. If you wonder how could there be no x-intercept for a quadratic? You meant quadratic is a parabola. It looks either like this. It doesn't touch it. It doesn't go. It's like down on the bottom there. See? Or up there. Or up there. So it doesn't go through the x-intercept. It does not cut through like that. So that's why there's none. You can write that too. Yeah. But it's going to be the top one here because it's positive here. So anyway, y-intercept now. Now y-intercept is likely. It's always, there's always y-intercept. Yeah, always. So how do we do it? Y-intercept, here's the work. If you recall, y-intercept, you make your x equal to 0 and solve for y. So here's your y in place of f of x. 2 times 0, show the work here. You plug in all your x's with 0. Minus 9 times 0 plus 9. So the answer is just 9. Everything goes to 0. Like all that will go to 0. So you're left with just 9. So y-intercept is equals to y. 9. That's it. Just 9. Okay, next one here. Okay, same idea for sure, but you have a different function. So x-intercept, I'll remind you here, when you do x-intercept, x-int, you don't know what x is, but you know your y is 0, you solve for x. Y-intercept, your y is 0, you don't know what your x is. So you do it opposite. You do x-intercept, you make your y equal to 0. So x-intercept, here we go, we're going to do x-intercept now. So x-intercept of this one, you go, the g of x is y, so it's 0. That's your g of x, which is y. X minus 1 squared minus 38. We're going to solve for x. Okay, double check, copy. Yeah. Add both sides by 38. So you're left with 38 equals negative 2 x minus 1 squared. Yeah. And then divide both sides by negative 2 because you can. And then you're left with negative 40. I mean, negative half of 30 is 15, half of 8 is 4, so it's 19, negative 19. 38 divided by 2 is negative 19. Okay, we can stop here. Here we go. Why? Because if you square root both sides, your x going to have an I. See that? You can. Yeah, I don't like writing this part. Is a plus or minus here. You can do this. You can copy exactly on the side of the 19, the minus 19, plus and put a plus or minus there, but then you emphasize that that's I. So you can say something like, hey, plus or minus I 19, 19I if you want, 19I. That's not real. You can say that not real. So it's that when it's not real, it's not on a real plane. You cannot graph it. Therefore, x-intercept does not exist again. So you say x-intercept, none. Yep. Yeah. Any I in the answer anywhere in the x, in the root, nope, none. So y-intercept is easy. Let's do y-intercept. Y-intercept. Your y is your g of x. You plug in 0 for x, 0 there, minus 1 squared, minus 38. So continue y. Negative to stay negative 2. You're left with negative 1 squared here. So it'll be a positive 1. So it's turned into a times 1 minus 38. So it's just a negative 2 right there. But then if you combine it with 38, it would be negative 40 for y. Done. Double check here. 0, 1, negative 2. Yeah, negative 2. Basically, negative 2 minus 38 is negative 40. Yep. So that's that for that one. Yeah, this one will be like somewhere here. The graph will look something like that.
Yeah.
Okay. Is that the last one?